Welcome to the lecture on problem solving on depreciation and depletion. So, in this lecture we will solve problems based on depreciation methods as well as depletion methods. Let us see the first problem. The problem is like this, that a machine was purchased for rupees 1,60,000 with life of 5 years and estimated salvage value at the end of its life as rupees 17,500. Basic declining balance method of depreciation is to be used. So, we have to find what should be the rate of depreciation which will make the book value at the end of its life equal to its salvage value at that time. So, we have studied the basic depreciation methods in which we know that there is a fixed percentage of the first cost of the asset that is used as the depreciation in the first year, and every time the book value is calculated, that percentage times the book value at the end of previous year will be the depreciation charge during that year. So, if we solve this problem, let us see what are the data which are given to us. So, we have first cost of the asset, that is P, given as rupees 1,60,000, 1,60,000. Then estimated salvage value at the end of 5 years, F is given as, that is also can be written as B5, book value at the end of 5 years, and it is given as rupees 17,500. Life is 5 years, so N is 5, and rate of depreciation, it is given as 0.1, 10%, that is 0.1. So, this is alpha. Now, we have to find this rate of depreciation. I am sorry, this rate is not given. We have to basically find this rate such that you get the book value at the end of 5 years as 17,500. Now, what we see, if alpha is the rate of depreciation, so let rate of depreciation be alpha. So, what we see from the formula of declining balance method, B5 will be P times 1 minus alpha raised to the power 5, and B5 is given as the salvage value at the end of 5 years. So, you can substitute the values. So, 17,500 will be equal to 1,60,000 multiplied by 1 minus alpha raised to the power 5. So, 1 minus alpha raised to the power 5 becomes equal to 17,500 divided by 1,60,000, that is equal to 0.1093. So, if we get the value of 1 minus alpha, it will be 0.1093 to the power 1 by 5, and this comes out to be 0.642. So, we get the alpha value, that is rate of depreciation, as 1 minus 0.642, that is 0.358. So, basically this is the rate of depreciation, that is 35.8%. If that percentage of depreciation rate is used, you will get the first cost to depreciate at the value of 17,500. So, this is our answer. Let us move to second question. The second question is, a company got a contract of mica mine for rupees 17,50,000, of which the value of land was rupees 2,50,000. Approximately 60,000 kg of mica was expected to be mined. So, the company has got this contract, it has bought it, and it expects that of this mine 60,000 kg of mica will be mined during the contract period or so. During the first year 4,000 kg of mica was mined. What will be the depletion allowance for the year? So, this is a problem based on depletion. In this there are two costs, one is the contract cost, that is of 17,50,000, and of which the land value was 2,50,000. So, basically the land is non depreciable. So, this will not be considered while calculating the depletion charge. So, in this question your amount which was initially invested, that is to be taken into account while calculating depletion allowance. So, the cost of land is will be subtracted. So, it will be 17,50,000 minus 2,50,000. Because land is not depreciable. So, it will be rupees 15 lakhs. Now, the company expects that it will mine 60,000 kg of mica during the period, whole period. So, your unit depletion rate will be 15 lakh multiplied by 60,000, that is 25. So, it will be rupees 25 per kg of mica produced. So, this is the unit depletion allowance which the company can claim for every kg of mica it mines. Now, it has mined 4,000 kg of mica. So, depletion allowance during the year will be 25 multiplied by 4,000 rupees. So, it will be rupees 1 lakh. So, this rupees 1 lakh is the depletion allowance which has been taken as the answer for this question. So, basically here it is similar to the cost percentage basis of depletion, and also the same concept as unit of production method is adopted. It has been used here to find the answer. Let us go to the next question. Now, in this question it is written that an office equipment has been purchased at the cost of rupees 6 lakh and has an estimated salvage value at the end of its life of 10 years is rupees 1,20,000. Calculate the assets depreciation deductions and book values over its depreciable life using straight line method, double declining balance method and SOYD methods. Also calculate the depreciation deduction and book values at the end of each year using markers if the property belongs to a 7-year property class, class life being 10 years. So, basically in this question we will try to have the deduction of depreciation charges, calculation of depreciation charges for every year using the 4 methods which we have studied so far. So, we will solve this question. Now, in this question it is given as P as rupees 6 lakh, N as 10 years, useful life of the asset is 10 years. This life will be used for the 3 methods, straight line declining balance and SOYD methods. However, it is a 7-year property class. So, makers will use the 7-year property class and based on that the calculations will be carried out. Salvage value at the end of 10 years is written as 1,20,000. Now, if we take, so let us calculate the depreciation charges during the year and also the book values at the end of each year. So, for a straight line method, we know that annual depreciation charge will be P minus F upon N. So, it will be 6 lakh minus 1,20,000 divided by, it has a 10 years life. So, 10, so it is 48,000. So, every year we can decrease this amount from the book value at the end of previous year and we will get the values. So, if we calculate the depreciation schedule, year depreciation charge and book value at end of year, depreciation charge during year. So, this is straight line method. In that we go to the first year, initially we take 0 year, the value is 6 lakh. Now, if you go to first year, depreciation every year is constant. So, it will be 48,000. So, it will be 552,000. So, this way we will go 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, every year the charge will be same, that is depreciation charge will be same. Here it will be 48,000. So, it will be 504,000, again 48,000. So, it will be 456,000, then again 48,000. So, it will be 408,000, 48,000. So, 3,60,000, then 48,000, we get 312,000, 3,12,000, again 48,000. So, it will be 2,64,000, 48,000, it will be 2,16,000, then in the 9th year again 48,000, it will be 1 68,000, and in the 10th year again 48,000, and it comes out to be 1,20,000. So, this is what you get. You have the salvage value at the end of 10th year as 1,20,000, you got it here. So, this is done using the straight line method. Now, let us see using the SOYD method. So, in SOYD method, SOYD can be calculated as 10 into 11 by 2. So, it is 55. Now, we will calculate in the same way. We have year, depreciation charge during year, and book value at the end of year. Now, in this case again at 0 time you have 6 lakh. Now, in this case using the SOYD method, depreciation charge during the first year will be 10 upon 55 into P minus F, that is 6 lakh minus 1,20,000. So, it will be 10 by 55 into 4,80,000. Now, in the second year it will be 9 by 55 into 4,80,000, and so on. So, ultimately you will be having the book value at the end of 10 year as same as 1,20,000. So, in the first, second, third, fourth, fifth, sixth, 7, 8, 9 and 10. Now, in this case we will have the first year depreciation charges 10 upon 55 into 4,80,000. So, this is 87,272.72. So, it is here. So, it will be 512,727. We can take it as 3. So, it comes like this. Now, we will have the second year depreciation. The second year depreciation will be 9 by 55 into 6 lakh. So, it will be 9 divided by 55 multiplied by 4,80,000. So, it will be 78,545. So, 512,727 minus 78,545, it will come as 434,182. Now, third is D3, that will be 8 by 45. So, it will be 8 by 55 into 4,80,000. So, it will be 69,818. So, 434,182 minus this amount 364,682. 364. Then in this fourth year you have 7 by 55 into 48,000, it will be 61091. 364 minus 61091 will be equal to 303273. So, this will be 6 by 55 into 4,80,000. So, this way you can go and calculate the different values, and ultimately by subtracting it you can get the values. Now, in the similar way it will be 5 by 55 into 4,80,000. This will be 4 by 55 into 4,80,000. This will be 3 by 55 into 4,80,000. This will be 2 by 55 into 4,80,000, and last will be in the 10th year 1 by 55 into 4,80,000. So, this way you can calculate the values and have this. Once we have the depreciation amount here, this can be subtracted from this to get the book value at this time. So, this is how you solve the depreciation problem based on SOYD. We will solve it using declining balance as well as markers. Now, using the declining balance method, and that to double declining balance method. So, P is rupees 6 lakh, N is 10 years, F is 1,20,000. Now, using DDB, double declining balance method, rate of depreciation will be 2 times 1 by 10. So, it will be 20%. It comes out to be 0.2, that is 20%. Now, we will use the table again. We have year, depreciation charge during year, and book value at the end of year. Now, in this case we have again at 0 year end the value is 6 lakh. Now, rate of depreciation is 20%. So, in the first year 20% of 6 lakh, that is 1,20,000. So, it comes out, the book value comes out to be after the end of first year 6 lakh minus 1,20,000, this is 4,80,000. Then in the second year 20% of this amount, so this will be 96,000. So, this comes out to be 3,84,000. 4,80,000 minus 96,000, 3,84,000. So, in the third year depreciation charge will be 20% of 3,84,000, that is 76,800. So, it comes out to be the book value at the end of third year comes out to be 3,07,200. So, in the fourth year 20% of this amount, so this will be 61,440 and this will be 245,760, 2,45,760. Then in the fifth year you get 20% of this. So, 0.2 times 245,760, it will be 49,152 and book value comes out to be 196,608. Now, the 20% of this will be depreciation charge during the year 6, it will be 39,322. So, 196,608 minus 39322, it will be 157,286. Now, in the seventh year the depreciation charge will be 20% of this, it will be 31457. So, 157,286 minus 31457, that is 125,829. Now, if we calculate the depreciation charge during the 8th year, it should be 20% of this amount and this comes out to be 25,165. So, if we take 25,165, then it is decreasing to a value something close to 1,04,000 or close so. Now, the salvage value at the end of its life is said to be 1,20,000 only. So, the book value cannot go beyond this salvage value. So, basically we have to use the adjustment basis so that the salvage value comes out to be not less than 120,000 or it should be coming as 1,20,000. So, in that case this will be not be used, basically we will use the depreciation amount as only 5,829 and that is why it will come as 1,20,000. So, this is basically the adjustment what we had earlier discussed in the case of declining balance method, so that you get this value. Later on during the two periods your depreciation will be 0 and the book value remains out to be 1,20,000 at the end of 10 years. So, this is the depreciation schedule for the double declining balance method. Now, let us go to the method of markers. So, as we had discussed that the markers uses the recovery period. So, in the case of that, now using markers, you have recovery period as 7 years. Now, for that we can compute the table and we see that what percentage of the first cost will be used as the depreciation charge. Now, if we go for the year end, it will go for 8 years. Makers uses the half year convention and DDB with switching to straight line. So, anyway our book value is 6 lakh. Now, we can refer to the Makers table for a 7-year property. In that the amount is 14.29% of the first cost of the asset. So, it goes for 8 years because this is a half year convention. We can get this table by calculating the values. So, the star shows the switching to straight line. So, in the first year it will be 14.29% of 6 lakh. So, it will be 85,740 and you can get as 514,260 as book value at the end of first year. Then in the second year it is 24.49% of 6 lakh. So, it will be 146,940. So, once subtracted from 514,260, it comes out to be 367,320. So, in the third year it will be 17.49% of 6 lakh. So, it will be 104,940 subtracted from 367,320, it comes out to be 262,380. So, in the fourth year it will be 12.49% of 6 lakh. It is 74,940 subtracted from 262,380, one 187,440. Next is 8.93%. $53,580 minus, so 187,440 minus this amount 133,860. From here there is switching occurring. So, 0.0892 multiplied by 6 lakh, this will be the amount 53,520. .92% of 6 lakh. So, $83,440. Now, we see that this 8.92 is going for 8.93 again percent. So, 8.93% again, it will be 53,580. So, 83,440 minus 53,580, that is 26,760, and this is nothing but it is the half of this. So, this is 4.46%. $6 lakh. This is 26,760. So, it will be 0. So, in the Mackers, as you see that the whole cost is recovered and you get the final salvage value as 0. So, this is how the Macker system works. We solve the problems based on Mackers for any property class using this table. Thank you.